So, hello and welcome to our weekly live stream. And today I'm really proud to host an author of Policy as Code book, Jimmy Ray, which I saw the book. I actually already bought one. And that's for some can consider a niche book, and for some can consider a lifesaver book. So this is why I'm proud, because for me, a book about policy languages is really something that I can use every day. And we also have Omer, an engineer from Permit, who spent a lot of time for the last 2 years in writing code in policy languages. And I'm really happy to host them today. But before we start and let them introduce themselves, a couple of announcements. So the first, I want to thanks every week to Permit that allowed me to host this live stream that I really enjoy to have this weekly discussion about topics that really uh, weirdly make me happy. And I was also want to remind you that we are recording the live, so if you need to drop off, no worries, you'll get the link after on email and you can complete the watch. And also, we really love to answer questions live. So if you have any questions, that drop it in the comment, no matter where you are watching us, could be YouTube, LinkedIn, Twitter, wherever we are living this live stream. We'll see the comment and we'll answer them again, trying to answer live. But if you prefer to not interrupt us, we also have 5 minutes at the end of the hour to ask the question that you're asking. We'll leave time for you to ask questions. And with that said, let's get it started. So, Jimmy, I'll be happy if you can introduce yourself.
Sure. Yeah, my name's Jimmy Ray. And as Gabriel mentioned, I wrote the book Policy as Code: Improving Cloud Native Security. And I, I'm primarily a builder, spent most of my time writing code, moved to the cloud like a lot of other people did, moved to Kubernetes shortly thereafter, spent a lot of time in containers. And throughout that journey, I picked up policy as code because it was basically, it was inevitable. It had to be done. So that's where I find myself nowadays is I actually do a lot more security these days than I ever did before. But security and governance, risk, and compliance and the automation thereof is a sweet spot for policy as code. So it kind of just folded right in there.
I can't hear you. Just one sec.
Yeah, I ask if you want to introduce yourself.
Oh, sure. So I'm Omer, as you said. I work at Permit for the past 2.5 years. In Permit, I build policy every day, basically. This is what we do. We generate the policy for our customers. Worked with optimizing policy with various languages, both Cedar and OPA. Also a maintainer for the Cedar Agent project, and a backend engineer in my heart.
Yeah, I think it's interesting because you both mentioned, I mean, when Jimmy talked about OPA and in the short discussion we have before, and you mentioned CEDAR, and I'm like, this is about OPA. No, this is about policy languages, and there is more policy languages than Rigo, and we'll get to that point later. But just you prove that this is a really good question to talk about the open policy agent dominance in the market. But I promise we'll get to that later. I really want to go back to Jimmy. You wrote a book. Tell me a little more about writing engineering book. What led you to write this book? How do you model?
So I think, like I said, I picked up policy as code. It was inevitable because I had to write controls at some point. And um, when I first started trying to write controls, I picked the only tool I had in my toolbox at that time, and that was Java. And I could do it with Java. The SDKs, I was working with AWS at the time, and the SDKs are very mature. However, I realized that this is not a real sustainable model because people that would read the policies and decide if the policies were the right controls, they would then themselves have to be Java subject matter experts, and that's not a sustainable model. And so I quickly moved to policy as code for those cloud controls, and that was, at the time, it was Cloud Custodian, and I still use it today. So, like, 8 years later, I'm still using Cloud Custodian. And I realized that there is a lack of common knowledge. I mean, there are silos of different policy as code solutions, but there was a lack of common knowledge around what is policy as code and how do you use it and what are the expectations for policy languages and engines and those things. And I had spent a lot of time using Custodian and Open Policy Agent and Kubernetes and different tools within Kubernetes, like Kyverno. And I realized that I had a wealth of experience. However, being a subject matter expert in a specific subject like policy as code is different. When you're using it, it is different than when you have to write about it authoritatively and correctly. And so the book let's say it was a labor of love, but it was a lot of labor. And I spent a lot of, late nights learning things that I already thought I knew. And then when the book gets to a certain point, you bring in technical reviewers, and thank goodness for those technical reviewers, because they helped me out a lot. There were people like Anders Eckert from Styra, that he's forgotten more about Rego and OPA than I will probably ever know, and he helped me out tremendously. And other folks from Kyverno as well, or Nirmata and Kyverno both, and and for that matter, the folks from Stacklet and Cloud Custodian project. And so I love to learn, so it was a fantastic opportunity for me. But it was a lot of work, and I'm glad that it is done. And I'm now looking to see. I look at the errata a lot to see how many errors I've made and how we're going to fix them in the next printing of the book. But
Yeah. Are you going to be, by the way, at the KubeCon in a 3
yeah. I'm going to be in KubeCon North America in when is that? That's in November, right? The 12th through the 15th, and in Salt Lake City. And I'll be on a panel talking about policy as code for artificial intelligence.
Oh, wow.
And then I'll be doing a fairly large book signing event there as well, like 2 days of signing books. I want to say it's like 100 or so books that we'll be signing. And so, yeah, I'll be there for the duration signing books. So if anybody wants a signed copy, they should stop by the Kyverno and Nirmata booth.
Yeah, I'm sure I will. And that's interesting, because you mentioned Custodian and you mentioned like Kyverno and stuff like that. But for you, Omer, I know that policy as code is very far from admission. You are working mainly on a different use case of policy as code. Do you want to tell us about your particular experience?
Yeah, so in my particular experience, we in Permit, we generate the policy for our customers, but for application authorization. So basically, everything that your application does need to be authorized. So policy as code, in that matter, authorizes or help you authorize the every endpoint or every, let's say, task that you need to do in your application.
So I don't see it mutually exclusive, right? I mean, I don't see that in particular, when I look at Kubernetes and the validating emission controllers, the dynamic emission controllers. To me, validation is sort of it's a method of authorization to allow this change to go forward. If the change fails, validation, then we're preventing an unwanted change from happening. And so from a permissions perspective, you could argue that there's an explicit bright line between permissioning and validation. But at the end of the day, you're permitting the change to go forward or you're not. Now that's downstream of you checking, authentication and authorization. But it's still, to me, I look at it, validation is a form, especially in Kubernetes, is a form of allowing this change to go forward. So to me, it's almost like permission, but it's when you guys talk about what you do in permit IO, it's way more beyond what I'm used to with respect to permissions. So I'm interested in learning more there as well.
Yeah,
Yeah,
I think.
the difference I think between the validation and the permission is that permission has to have user in this uh, in this scenario. So validation, you have an input you want to validate, and you basically have an output of boolean validated true or false. But when you authorize something, you specifically say there is an authenticated user that I want, or unauthenticated user, let's say, that I want to validate that this authenticated or unauthenticated user can do the specific thing that he wants. So I think the user here is the thing that distinguishes between the validation and authorization.
Yeah. In my opinion, and I'll be happy to hear after also what I have to say, your angle on it, because if we let's imagine like a Venn diagram of permissions and validation, and policy as code can solve both problems. But what I think exists in permissions that do not exist in validation is two things. So user, or Omer mentioned the user. But I think the user in general is the problem of data. In permissions, you have much more data that is involved in the decision than you have in validation. So that's the first thing. And this data is not about only the amount of data; is about the dynamics of data and the way that it can change from permission for permission very fast. So that's the first thing. And I think the second thing that is different is the need of permission in query permissions, not only get the true or false result, but also, for example, ask what resources or what kind of data this user is allowed to, and get the non-binary response to that. Do you think it also exists on admissions and validation, or this is exclusive
Depends,
problem?
I mean, Kubernetes is like the only system, one of the only systems that has, a built-in validating and mission control layer that actually will prevent unwanted changes before they happen. If you look at all the cloud service providers, it's kind of like reacting after the fact. Now you can react sometimes within subseconds of an event, but it's still reacting. And um, but if you look at Kubernetes and the way that validation happens, event-driven validation through the API server request flow, that brings with it the review object, and inside the review object is user info. So you could have some user info as part of that review object. When you switch from that validating and mission controller that's event based and you move to like an audit or background scanning, so like you're periodically background scanning to make sure that you didn't miss anything during a validation cycle, because that's easily done depending on what your setups are for Kubernetes, then you can't use user info because it's not there anymore. It's not part of a user, client initiated call. So it's part of an audit or a background. So you can't, you wouldn't be able to use a policy that used user info there.
Yeah. I want to ask, so policy languages require at least an engine or a compiler or interpreter, whatever you call it. I mean, whatever the term you decide to call this language compiler. What other tools do you think need to be involved for efficiently running of policy engines? And or maybe let's have a pre-question for this one. Do you think there is a tool that needs for all the use cases? So, for example, that's for sure that if you want to do validation, you need something like Gatekeeper, like Evernote, that will know what to do with the result. Or for authorization, you need a data engine. But there is some tools that you need for any kind of policies code work you do. And start with you, Jimmy.
Um, so yeah, so when I look at the tools that are provided by a let's say a policy engine or a policy language set of tools, I look at optimization, formatting, linting. If you look at some of the enterprise platforms like Styra or Stacklet or Nirmata, you start to see additional things like libraries, snippets, examples. A lot of times when I start writing Rego, I go out to the Rego playground and start working online, because it's so easy to use and there's so many examples out there. But then you also have extensions and integrations that, a fully, I'd say, mature policy language would have extensions and integrations. And so, and that also is, you see that in a lot of the existing tooling out there.
Yeah. Omer, do you think that there is any like tooling that needs to be added on top of the compiler for general case? So Jimmy did mention, and we'll going to get that soon about the complexity of Rigo, about linting and cleaning. But do you think there is any functional tools that most of the engines is missing, and that's supposed to be part of the engine?
Um, so as Jimmy said, like some of the engines has integrations and plugins and stuff like that. And I personally also wrote plugin and extension for Open Policy Agent. Um, but when we need to handle like large volume, um, then some engines are not suitable for that because they store the entire JSON or whatever they store in the memory, and it takes like a lot of time both to allocate this memory and iterate this, and sometimes you need to do indices on this JSON because it's JSON, it's not like easily searchable or something like that. So for large volumes, I think the policy engines do need to add some, I don't know, plugins for that.
You talk actually about the data volume problem, and
Yeah.
I'm curious to hear from you. I mean, we all know fine-grained authorization. Data volume is a problem of fine-grained authorization after 2 months that you are using like fine-grained authorization solution. But Jimmy, do you find that data volume is also a problem with admissions and other areas where you use policy as code?
So I see, if you look at Kubernetes in general and the admission process there, the or the time it takes to validate can be an issue, right? Because you only have but so many seconds before Kubernetes responds either with, it can't validate at all, or it allows it to go forward because it couldn't finish validation, depending on what your settings are, fail open, fail closed. And I think any system over time, the volume of the requests will grow. And validation happens in parallel, so you could have multiple parallel requests. Mutation before validation happens, serially. But so I think any system, there's a possibility of overcoming the underlying window of execution because of the volume of data that you're bringing in. So, and I guess what that leads me to is any system requires the ability to tune that and look at maybe fragmenting or doing partial evaluations, so to speak, of the data, shortcutting some of your decision points, which is to me a form of optimization.
If I'm thinking about it, so I'm trying to compare it. I know it's not that accurate comparison, but I'm trying to compare it to, I don't know, languages with compilers, right? So let's talk about Java, C++, whatever it is. The data volume is not a problem of the language of the or the compiler. It's a problem of, it's much wider problem. It's a problem of the computer architecture you have, of the deployment architecture you have. But for many, when talk about policy as code, they mention the data volume as something that is part of the policy engine, part of the compiler. Do you think, Jimmy, that by using some best practices, we can achieve a way that we separate the concerns, separate the duties into a form of into a situation that data volume is not a problem of the engine anymore?
So I think, yeah, I mean, I think there's a set of heuristics that you probably should adopt when you're choosing a policy as code solution for your use case. And not all policy as code solutions work for every use case. Obviously, some of the policies code solutions that I've used have grown and they support other use cases than when they started out. When I started using Open Policy Agent back in 2018, I think it was, from the beginning, at that point at least, it was domain agnostic. I could use it on just about anything, but I was writing controls inside Kubernetes, and I had other solutions that supported, policy as code inside AWS, where I was also spending some time. So for me, when you pick a solution, and I talk about this in the book, how you pick a solution to match your use case and all the different things. But one of the things you need to touch on is operationalizing that solution. And part of operationalizing that solution is understanding, what are your boundaries? And, you may not see your boundaries right away if you're doing a proof of concept, but you will see your boundaries at some point when you start to overcome the payload, and the in-memory representation of that payload, when your policies have to act on that payload and make a decision for you. Sooner or later, those payloads are going to overcome your system, and you need to understand, how do I now streamline those payloads.
Omer, I know that you're working now on a very interesting project of having persisted layer for OPA using SQLite. And I think that actually kind of support or like solve the problem of data volume. Do you want to give a few words on that?
Yeah, sure. So what I'm working on right now is basically a project that allows you to store everything you need outside of OPA, or at least the the volume type of data outside of OPA. Then you can query it efficiently before or even in OPA using plugins from the tests I did. So querying it before is faster. So query it before, then inject the data in the input and like only the relevant data. So let's say you have half a giga or few gigas or even 1 tera of SQLite DB. So you don't need this entire data for every valuation request. So you query only the few megas that you need. You send them in the input, and the few megas is a lot for like an input for evaluation. You send them in the input, and then the evaluation goes fast. I was actually surprised to see that policy engines in general don't have a solution for that, because in terms of optimization, they do have solutions like profiling and stuff like that. But for memory optimization, it's basically you need to like look at yourself and find your own solution.
I think it's interesting what you said. I just in my head I cooked a lot of question now about Jimmy mentioned on what to choose, but I want to ask you because I know you worked a lot on the Cedar engine, and I know that one of the promises that Cedar bring is the verification and the way that you can have scientific proof of permissions, and also about the schema of the data that could help you with that. Do you think Cedar is really solves that problem, or it's just nice on the as you said, nice in the profiling, but in a real world you still need to have your own scale for such volumes?
Yeah, so Caesar basically forces you to send the data that you need for the request in the input. So CIDR don't store any data. CIDR in general, it's basically a package or a crate. In Rust, they have bindings and stuff like that, but it's a package. So it doesn't store anything. It basically gets the input, the entire input it needs for the evaluation, and it returns the output. The CIDR agent, the open source that I built on top of that, is a web server that do allow you to do such a thing, like storing the policy, storing the schema, storing the data even. But for high volume, it has the same problem. So CIDR basically are
I think
telling
I think
us
I think
you
it's
need to
about
do this in the
approach.
input.
Yeah, I think it's about approach because I actually thought that there is a way in the Cedar crate itself to store data or to make it access to data. I didn't know it's part of like the wrapper that you need to write. But if I'm thinking of it from the abstract perspective of consistency, so the consistency that you describe of you need to send the data in any input is means in general like read your writes consistency. What you read, I mean, what you write is what you read. This is the exact verified data that the exact verified permissions that you can do. Do you think that engines that work in by default with read or write consistency create this separation of duties that say, okay, the compiler is the great that it can, and you will worry for handling large data volumes of like large volumes of data.
So
Or let me ask it differently because I want to, especially because I want to get a shorter answer. But would you be happy if OPA by default also has capabilities of read you write, and you will have to write the layer of data synchronization that can help you model it by your needs?
um, so obviously, yeah. Like I would be happy if they add something like that out of the box. Like that you can inject this in the UPA somehow or configure it or I don't know what. Um, but in terms of volume, I do remember when going into their documentation that they did I'm not sure if it's like some sort of experimental or POC or something like that, but they do have like storing the data in a file, but it's not performant, and looking at like lookups on that file is very slow, and I've never even tried that because of the project I'm working on. Um, but they are aware of the problem of data volume.
So I had a question, I guess, regards to what you're working on now. In OPA, you have a document model, right? And
Yeah.
you have base documents and virtual documents. And base documents are essentially just data you load into it, right? Beyond the request input, and then virtual documents come from the processing of your input, your request. So what you're saying is, even if I were to even if I knew ahead of time that the use case I'm solving requires a lot of data that's not part of the input request, and so I would load that data, as a collection of base documents, let's say, the that amount of data over time, given the size of those base documents, would somewhat overwhelm the system, um, because of how large they would get inside, like an OPA service.
Yeah. So imagine that you have, let's say, a single file, right, on Google Drive, and you have like tens of thousands of users that has permission for that file. And you want to ask the basic question of who can access this file, right? So this data changes all the time. So like you have to store it somewhere. So usually we would store it in the policy engine because it has all it needs to evaluate uh, like who can access what. But when you have lots of data, so OPA will just allocate a lot of memory because in in terms of memory allocation, it isn't the best. Like for each object, I think it consumes. I don't want to give a rough number because I don't remember, but it consumes a lot of memory, and you would get to the issue that I've talked about.
Okay. All right. I mean, that makes more sense to me. I think, I mean, I've seen patterns where they segment the access control that they're trying to model with OPA. They segment it by placing the policy decision point close to the policy enforcement point, right? I mean, there was a example that Netflix had out there years ago where they had these satellite OPA agents, right next to the
Yeah.
policy enforcement point, right? So the decision point was there, and they had replication of data that was uploading into those OPA agents, but it was very segmented data based on what decisions had to be made at that policy enforcement point. Um, Outside of artificially segmenting the data with different OPA agents, yeah, I could see where things could grow, as the monolith of the OPA agent that's servicing all the different, decisions, that could grow pretty big, I guess.
Yeah. So one of the solutions is basically exactly what you said, to segment or shard the data that you have by something, and then have multiple OPA agents. Each one has the relevant data only for this specific shard, and then when you need to query something, then you go to this specific shard. But in terms of um, graph permissions, it becomes a bit tricky because you need to understand which object is connected to which object and make all the objects that are connected in the same shard, because if you want to ask permissions on one of them, the graph might grant you those permissions.
Yeah, I think this is a really good dive into the data plane, and we also got a question from Rohit. Thank you, Rohit, for sending that. Great to dive into the data plane. How do you keep it secure and fresh too? The integrity of a PDP depends on PAP and PIP. Does Jimmy have some tips or way stories? I'll say that just open for people who are not from the IEM field or not familiar with the ZACML model. PDP is policy decision point. In comparison to OPA is, of course, the engine itself that get a decision. PAP is the administration layer that actually manage the policy engine. Can think about it. I don't know. I mean, in the world of admission, maybe we can call like the Kubernetes service for admission, like the PAP, and PIP is where the data came from. And so yeah, Jimmy, let's answer that and then move from the data plane to more interesting. Nah, not really. Data is
Okay.
actually
I mean, I think, one of the models that I really like when it comes down to securing the data plane, I really like the idea of using the Styra model where I submit bundles, or I build bundles within the Styra solution, and then I have those bundles downloaded to my remote uh, OPA agent that is also loaded via Styra configurations, and everything is secured that way. The bundles are signed, and then those signatures are checked. So the that's one of the best ways to secure your data plane is what data is going into your agent. And I think the Styra solution offers a good way of securing and managing very minimal connections to your OPA agent. But I'd be open to hearing what everyone else thinks as well.
yeah. I think great summary. Admission, configuration, and distribution in more Kubernetes agent term. Yeah, I think Rohit is always have a great insights and also then great compliments. I'll say that in general, it's very interesting to see the way that admissions and authorization going hand by hand at some point and separate ways at some point. Because if we are thinking, for example, on the kind of, let's talk, I mean, I don't want to stay long for the data itself, but let's talk about, the tunnels that actually getting the yeah, another comment by Rohit, a warning that policy data becomes an attack surface too. Thank you.
I mean,
Yeah.
that's true. I mean, that's a good thing to touch on right there. When you look at policy as code, it can be a constituent part of governance, risk, and compliance, which is all about reducing attack surfaces. So I see GRC as part of cybersecurity, and I see policy as code as part of that as well by extension. However, it's very easy to, and I started this out in like I want to say chapter 14 of my book, where I talk about software supply chain security, and I talk about how we could use policy as code tools. And then I had to go back and say, oh, and policies code is code. So you have to use software supply chain security tools on that as well, because that's another attack surface. And so, I mean, that's a very good point there, Rohit.
Yeah, well, I hope we'll get to that, but I really wanted to ask a question about the infinity loop of policy for policy for policy. When is that end up? But we'll get to that because I really want. I mean, I promised policy language. We talk about engines, we talk about data, and I think it's a core topic. I bet if people that who has some familiarity with policy languages that arrived here got a lot of great insight. But let's go back a little to the bare bones. I know personally, like I used to use three types of languages when writing policies. I used to use the multi-purpose logical language of Rigo for Open Policy Agent. I used to use the declarative language of CEDAR for declaring policies in CEDAR language. And I used the expressiveness form of declaring language for OpenFGA that I got a chance to choose from. And there are some policy language that you can consider as imperative. I want to ask you, like, what is your favorite flavor for policy language? So let's start with you, Jimmy. The favorite flavor.
So, I mean, it's use case based, right? I mean, yes, Open Policy Agent is domain agnostic. We all know that, and it truly will. It doesn't care what the domain is. You send it data and policies, and if you can match a policy to a data, it will react to that request. So that makes it very general purpose. And I started out using it in Kubernetes, and then I worked with the Gatekeeper project, and then we started using Gatekeeper, and then I started using Kyverno. And but what I look at, would I use Open Policy Agent in the cloud, so to speak, to detect events or do periodic remediation? I could. But there are other solutions that have extensions that make it easier to operationalize. And so that's why I'm a big fan of using Cloud Custodian for the cloud. But I could also use Cloud Custodian in Kubernetes. I could also use Cloud Custodian to do infrastructure as code. So, but I really like using OPA as well to do infrastructure as code. For that matter, I like using Sentinel when I'm doing Terraform. So I don't really have one language that I focus on. It really is use case specific because of the other tooling that language and engine brings with it. It makes it easier for me as a user to operationalize it across the environment in which I need to write the controls.
No favor, just look at the use case and understand if you prefer something. Omer, do you have any kind of
Yeah, so I actually agree with Jimmy because basically every use case has its own its own language. So similar, like if you develop anything else, because policy is code, right? So if you need to develop something fast that I don't know, you will have very much like a big community and easy to write and easy to read and stuff like that. You would choose any high level language. right? But if you need something more performant, you would choose low-level language, right? So it's exactly the same in policies code. So
Yeah.
sometimes you would choose Cedar because it's easier to read, and I don't know, it's a deterministic way of knowing what would be the answer. But sometimes you need something more like agnostic, so you would choose OPA, and sometimes you would need the graph of OpenFGA. Right? Every use case has its own
Yeah,
engine,
I
in my
think
opinion.
I think OpenFGA. I think OpenFGA. It's interesting because in the last week live stream we've been with domain-driven design guys, and they mentioned that OpenFGA. The thing is not about the engine. Is I mean, many people who are talking about Zanzibar and engines that do data analysis for decisions, they are mentioning the model of the graph itself. They're mentioning the model of the engine. But what Jimmy brought is that he liked the expressiveness. He need an expressiveness language that helped him to adapt the use case for business use cases. But that aside, Troy, the real thing, you did a comparison. You compare like programming languages for general application into policy languages. But from what I know, not all the policy languages are so intuitive. So Rigo, as its multi-purpose engine, use the logical languages. If I count the languages I used to write, let's say minimum 5 lines of code, I wrote in maybe 12 languages, 15 languages in my life. Only one was a logical language. And that could affect the usage, right? It's not intuitive for most of the developers. If you're choosing like declarative language, declarative you have any everywhere, right? You have it in format in like structuring like languages like JSON and YAML, but you also have it in Terraform. Let's say logical is not that intuitive. Jimmy, do you think this is a price people should pay just to use OPA?
So I there is a learning curve to Rego. I think that the tooling now makes it easier. Like for instance, the Regal linter from the open from Styra, the is a fantastic tool and it helps you learn quickly. And and other tools help you learn it. But I'll be honest, when I was I came upon OPA in 2018, almost 20 years after I started writing Java, and I at that point I looked at the syntax of OPA and I just assumed it was imperative, and it is not. And so it's not just that it's a assertion based logical language. It's syntactically similar to what you would see in other Java, Go, C like languages, right? And um I think that made it, for me personally, made it harder because I had preconceptions that I had to completely unlearn. And then the whole idea of Rego's truthiness, where you think something should be false when actually it's true because of the truthiness of, and I call that out in the book as well. There's a certain truthiness to the uh, the rules when you write them in Rego. You have to understand that because you can assume that you don't get the right value back, and you can assume that it would be false when in actuality it is actually true, and that makes it difficult to troubleshoot your rules that you're writing. So I mean, I think there is a learning curve. Now I think you get to a point where you've written enough Rego, and what helped me a lot when I was writing the book was the Regal linter. I got to that point and I realized, wow, it's much easier after linting to understand this code. And I think that will help newcomers to Rego learn quickly, let's say more quickly than I did.
Yeah, it's interesting. So you said there is a price of the learning curve, but there is also tools that can help you with actually make it better and make it work for you know like easier implementation. I'll ask it from a different perspective. So I saw not many, but some organization, developer organization or IT organizations, that decided to streamline everything related to policies into one solution. Like, so it can, it can help with compliance, it can help with regulation. So they say, okay, we have this policy repo and everything is here. So it could be, for example, bridge the like enterprise IT and application authorization. Could like streamline admissions with some infrastructure API permissions. Do you think that if someone chooses something, they should choose? I mean, if someone choosing something that is multi-purpose, it is better to go with OPA as a multi-purpose engine and pay the price of a lot of customization for some use cases, or is it better to go with multiple engines for multiple cases?
Well, I mean, my opinion, based on my experience, is that I like multiple engines for multiple use cases. Again, based on the extensions of those engines and the languages thereof. Um, but it really comes down to your organizational capabilities, and because I cover in my book, I've seen languages, policy languages written in JavaScript, um, and languages that transpile into JavaScript, like TypeScript, right? And so I've seen those languages, and again, if I were an organization where I had a deep chops in JavaScript, maybe that's a solution I would pick. That being said, when I look at a language, a policy language and an engine, I look at it, does it distill the simplicity from the underlying complexity of the system it's trying to apply controls? I don't want to be a subject matter expert in the cloud SDKs, or for that matter, the Kubernetes SDKs. I don't want to be that expert. I want it lifted up, a layer, so that I can just write a domain specific language like that's based in YAML, or you can argue that Rego is certainly a domain specific language. So I want the complexity removed for me, and to me, that's one of the biggest promises of the modern policy languages, is that they fit a specific use case, but they also abstract away the complexity that is the underlying API. And all you have to pay attention to is, have you learned enough of the lexicon and the syntax of the DSL for you to now write your policies and not have to understand that it's making these multiple API calls under the covers? That's the part that to me is the biggest promise of a modern, policy language.
Yeah. I think that Rohit bring here another question, and I want to. I mean, you referred that to Jimmy, so I want Jimmy to answer the question. I'll read it soon, but after that, I have a follow-up question on that. Just a comment on the policy for policy for policy. So instead of the way I plan to ask that, let's have the Rohit format. Just a quick comment on the policy for policy for policy. Look for Jimmy. Is there more positive language for hierarchical abstraction? Is there like rule, policy, regulation, law, constitution, principles?
It's a difficult question for me. I think I'm looking, in the last chapter of my book, I talk about a couple languages. Q is one of them. I'm looking at Q because it takes with it the underlying format's not the right thing. The underlying concrete expression of the language, and then it expands upon it for different objects, so to speak, based on an underlying concrete template. So I really like the Q approach there. And for that matter, if you took Open Policy Agent and you combined it then with a language that seems to have gotten some momentum around security, especially in the government space, I would say that would be OSCAL, right? So you could then combine OSCAL with Open Policy Agent to not only do the actual physical checks that you were doing with Open Policy Agent, but then satisfy the government, requirements to use OSCAL and provide the artifacts that OSCAL actually provides. So I think it's not necessarily just one language that does, what Rohit is asking about. It may be a combination of multiple, languages, depending on what the use case is.
Yeah. I think when I look at Rohit, it reminds me a discussion I had with David Broussard about the alpha language. And we discussed not the exact topic, but we discussed the problem of consistency, of eventual and strong consistency in relations to policy languages, like the old one of like Zanzibar versus policy as code. But so, Rohit, if that was a reference to let's bring alpha back to life, I'll be able to know about it. And I'm really fine with leveraging this platform for more and more policy languages. But I want to ask a question, like a follow up question of what Rohit mentioned. What Rohit mentioned is not must be a part of the language. It could be also part of the design pattern you do. And with OPA, because it's like multi-purpose, and you can write things with the code. Yeah, you mentioned it's like it's not a real imperative, but it's not also real declarative. You have the loops, you have the conditions, you have kind of functions, you have the extensibility. And this is actually what we did in Permit. So what we did in Permit, we are letting developers the SDKs and the APIs for modeling role-based access control, relation-based access control, and attribute-based access control. And then we are generating hierarchy that is kind of similar to what Rohit mentioned here. Do you think that developers who, just want to use raw OPA should use that with a sense of design patterns that keep strict this kind of hierarchy or something?
So when I was a programmer full time, I always considered myself a lazy programmer. I didn't want to reinvent the wheel. I wanted to use, I mean, that's the promise of open source, quite frankly. I wanted to reuse what other folks have, built. The trick is to find the right thing that, actually works and is sustainable and maintainable. I like the idea of not having to, I like the idea of applying patterns, because as a Java developer, everything was about design patterns. However, I like the idea of applying the, similar design patterns, and for that matter, authorization patterns using Open Policy Agent or, some other language. But the more tools or libraries or SDKs that a platform can offer, it just, it, like I've mentioned before, it enables operationalizing. It's an enabler. It enables the teams to hit the ground running faster and to be able to maintain over time. And it's not a point it's really not a one-time thing. I mean, these SDKs will continue to grow, the libraries will continue to grow, you'll get examples and snippets. To me, part of the adoption of any solution is how extensible it is at one point and how it will continue to be extended going forward. So yeah, I would agree with you that, yeah, I think being able, it's one thing to learn the core language, it's a whole other thing to operationalize it for your use case. And the more extensions and integration points there are, the easier that adoption will be.
Yeah. Well, one of the things that we did for that, we create another language for the policy language. So you can configure the Rigo rules or the Rigo particular schema parts using Terraform, and we will auto-generate the Rigo for you. I think we are mostly get to the end of the hour. We have the last 5 minutes, and I'm looking at the list of the questions I plan to ask. I maybe got to the half point. We should definitely do another one. I see another point from Rohit. So I agreed today many as code languages are best for each domain, although I meant in marketing terminology for reaching different job functions. Yeah, that's it. Right. Excited to learn about Q, OSCAL, EDC too.
Oh, and
Yeah,
one
I
more
think that.
thing, when you talk about Q, it's actually CUE, and I just call it Q. It could be something completely different, but I call it Q. I pronounce it Q because that's how it's pronounced in the English language, but it's actually CUE. So I want to make sure folks know that in case they want to go and look it up.
Yeah. So to kind of summarize this discussion and the topic, so we discussed the multiple use cases in policy languages, and then we really diving deeply into the data plane, and I think that was a super insightful and helpful discussion. I remind you, this is the last 5 minutes. If you want to ask any questions or do you have any topics that we can discuss in 5 minutes, just drop it in the comment, no matter where you're watching us. And to fill the gap until people are typing the question or just keeping silent, I want to ask a question that I promised that I'll ask. And I think there are some answers that answered in the middle, but I want to hear you both, like with one or two sentences on why does OPA have such market dominance? Let's start with you again, Jimmy.
So, I mean, it's domain agnostic. And even though Rego is a difficult language to learn, the Rego language is domain agnostic. And OPA, people need to realize that OPA is not just one project. There's like 20, last count, it was 22 projects in the Open Policy Agent Oregon GitHub. One of the things that I really love using is CompTest, because CompTest is essentially a wrapper around OPA that enforces a specific pattern every single time, and it does compiling of things into JSON that are not JSON, like Docker files, Java property files, other things that are not JSON. It handles that for you, detects what they are, parses them in on the fly, and then you can push them into OPA for a decision. So I mean, and there's like SDKs and for different languages like Go. I think Styra offers one for Java. So I mean, to me, again, I go back to it has grown, and Gatekeeper is one of those 22 projects, right? So I mean, it has grown way beyond what it was when I started using it in 2018.
Yeah, I'll say that from that perspective. So, for example, Opal, the permit project for wrapping OPA for data sync and policy sync, is also a very popular project. It has like more than 4K stars. And that's another example of a project that started. So, today, Opal is supporting also CEDAR and OpenFGA, and it's very agnostic for more policy engines. But that's also a great example on how being multi-domain can help you grow by satellite projects that could support the growth. So if you're thinking open source project, think of being multi-domain as an advantage, although it has the price for sure. Omer?
Yeah, so I agree with what you both said. So, in my opinion, integrations and being able to do basically almost whatever you want with OPA is the thing that made it the domain leader. This combined with being like very mature when policy as code became like a thing. So it was one of the most mature languages, and at least that I know.
Yeah, great. So we are getting to the end of the hour. Any conclusion words you want to say?
Yeah, sure. It was actually very fun talking with you, Jimmy, and Gabriel. Learned a lot also about what you wrote in the book and the stuff that you did. Hopefully, you also learned a lot from me, and that's it.
Yeah. Thank you very much, Jimmy. I'm going to wrap
Yeah,
up.
I think so. We've been using policies code for a long time, like me, about 8 years or so, and it's all been open source stuff, right? And just now getting into enterprise level stuff that helps operationalize policy as code. So we're hitting that point, where we've got enterprise support and tooling to help us operationalize what we've been doing in open source for a while. And if you look at where folks think policy as code is right now, they see it as like the very beginning of the curve, so to speak, where policy code is just now emerging as an enterprise solution, when in actuality we've been doing that for the last 8 years or so. So I think there's an opportunity now with the enterprise tooling to help more organizations adopt policy as code as a solution.
Yeah, I think that's a great word. So thank you very much, all. It was really fun. And next week, I'll not host the live stream. Next week, Daniel will host the live stream about documentation for developers. A fascinating topic that I really want to host, but I'll be in a vacation next week. So thank you all, and see you next